discuss about how to draw shear force and bending moment for this beam. So in this beam, what is the question given? This is a pin joint and this is a roller joint. So for pin joint, we have two forces. What I have taken is positive upwards and positive x direction as my reactions. Same in this one reaction will come. I have taken it upwards as my reaction. Next is, this is a slanted force. It is inclined at 30 degrees from the horizontal. Again, this one is a inclined force with a 45 degrees. So it will be having two components. So this will be resolved in this direction and in upward direction. Same, this one will be resolved in the downward direction and this direction. This is a couple and a force. When we'll be transferring this to this place, this will be transferred as 35 as the force and 35 into 0.5, that is a perpendicular distance. So this will be a clockwise moment. So this couple will come 17.5, and after resolving this will be sine 45. The values what we'll be getting is this much. Same we'll be doing for this. So next is we'll be identifying or calculating the reactions. So if we see, there is a horizontal forces and horizontal reaction also. We'll be putting summation h is equal to 0, and in positive x direction we'll be assuming as all forces are positive. So I am just putting all the forces which are going in the positive x direction as positive. So after computing this, we'll be getting 7.79 kilonewton. Doing it for all the forces in the vertical direction, I am taking upward as positive, downward as negative. So RA1 plus RB minus 20 minus 35 minus 42.43 is equal to 0. Next we'll be doing summation of all the moments equal to 0. We'll be taking moment at this point. So these two forces, since it is connected to this point only, will get cancelled out, and all the horizontal forces, since line of action is same, will get cancelled out. So this 20, this is coming clockwise, so 20 into 3. Then this 35, it is also your clockwise force. This one is also clockwise. This RB is your anti-clockwise force. This itself is a couple. Itself is a moment, so need not to multiply any distance from this. We'll be taking, since this is a clockwise, so we'll be taking is as positive. So we got all our reactions. This one is the axial reaction, this is the axial force, and these two reactions we got. So by all the three equilibrium equations, we got all the reactions here. Next we'll be finding out the shear force. So the points at which we are interested for our x is your 0, under the forces and onto the supports. So shear force will be finding out at x is equal to 0, then x is equal to 3, then your x is equal. So we are starting at x is equal to 0. We are standing at this point. So the sign convention what I am taking here is upward, and my clockwise is positive for my right hand side. So upward is positive here. These forces are negative. So at x is equal to 0, I am writing it minus 20 minus 35. Then your this force positive this, and it comes out to be minus 38.23. Next I'm standing at x is equal to 3 at this point. So I'll be taking left side and right side, both the forces. Left side I'm taking a sign convention as downward is positive for me. That is opposite of this. Downward is positive for me. So this one is upward force. So it will come out to be minus 38.23. And on the right side, I have this as minus 35, then minus 42.43, then positive 59.2. It comes out to be minus 18.23. When we are standing here, our sign conventions are opposite of this left hand side. So downward is our negative. So I have written upward as negative, downward positive. This will came. Right hand side, we are putting all the values and this will came. Now we are standing at this point. So upward forces are negative, downward forces are positive. We are getting this value. And then right side upward force only RB is there. I have written like that. Now we are standing at the end. So at the end we have this one is going up. I have written is negative, and all the forces are coming down. I have written is positive, and this will come. So these are all the shear forces. Next we are coming on to the bending moment. So x we have taken at 0, 3, 5, 8, 10. Similarly as your shear force we have calculated the same points we have taken. So at x is equal to 0 we have 20 and distance is 3, and this is coming clockwise, so I have written is positive. Similarly this 35, this is coming also positive clockwise, so I have written like this. Then this one is your clockwise, so positive, need not to multiply it with the distance, it itself is a couple. Then this 42 into the distance is 8, and it is also coming clockwise. This RB is negative, so I have written it like this, so it is coming out to be 0. Then we are standing at 3. At this point I have taken RB, so this was coming out to be clockwise. Left hand side we are taking different sign convention, opposite sign conventions, so it is coming out to be negative. And when we are standing at this point we have to take left and right both, because there is a couple at this point. So there is a critical change in the moment at this particular point, so we'll be checking left side and right side. After this we'll be going for the shear force. So first what we'll be doing, we'll be just pointing and writing all the shear force what we got. So all the shear force as per the sign we have written, and we will be simply joining it with the free hand. So whatever values are coming at x is equal to 0, 3, 5, 8 and 10, will be simply joining it. So here we go, and this is 38.23 negative, and this one is positive, so we'll be joining it, and this is our shear force diagram. Now how will we knowing that this particular diagram is correct? So see, under this load, this is your 20 kilonewton after the resolving. So the ordinates which is coming below that, it should be 20. So it is 38.23 minus 18.23. This will come 20. Next is your 35. So this plus this gives you a 35. Next is your 42.43. So this is R in same ordinate, so it will be deleted. Next is your this reaction. So both ordinates should be matching. So next is your bending moment. Bending moment, whatever are your values are coming, I have just simply kept it like that, and I am simply joining it. So under the couple, see, under the couple this kind of bending moment is coming, and it is a triangular bending moment. So like that I am writing. So this is your bending moment and your shear force. Thank you for watching.